Let's get into our new content then. So what we're going to talk about next is super important, and we're going to be using this function every semester. So I'm going to go back to our original example. The variable we're going to work with is the hours of sleep variable that we used at the start of class. I'm not going to use your data because I want to have easy numbers to work with, so I planned out the data in advance. And the values are going to be, we already said it, let's just say it could be 0 to 12. So let's go ahead and set up some data. I encourage you to copy this down and work along with me. I'm going to put P1 for person 1. Leave myself some room for headers here. This is our raw data. Okay. And now I'm going to put P1 for person 1. And person 1, I'll put X here. Remember, that just means score their hours of sleep. So person 1 got 4 hours of sleep. Person 2 got 8. Person 3 got 9 hours of sleep. Person 4 got 6 hours of sleep. Person 5 got 7 hours of sleep. And person 6 got 8 hours of sleep. Hopefully this data set would meet the qualifications to be considered normal. Even though we have that 4, which is a little bit lower, hopefully it's not a very strong outlier, and so we can move forward. So now, we're going to use for a measure of central tendency, the mean. So let's go ahead and calculate our mean. Our mean, as you know, using our new math language, is the sum of all the scores divided by the number of scores. All right. In this case, we know, I'm going to write this down just so we're clear. We know that the number of scores is 6. We have 6 people. All right. So if we go ahead and calculate the mean, mean equals the sum of 4, 8, 9, 6, 7, 8 divided by 6. When I write that sum sign, we know we're adding, so we just put commas in between the numbers, okay? If I could also have written 4 plus 8 plus 9. That equals 42, when I add up all those numbers divided by 6, equals 7. So the mean of this distribution is 7. So that gives us one bit of information about this distribution. But another helpful piece of information and essential for statistics is to understand something about the spread. So to understand the spread, let's draw a line across here that represents the mean of 7. What we want to know is how far each score is from the mean. So here we have this 4. We have an 8. I'm just kind of writing these scores as they relate to the mean. Here's our 8, it's higher than the mean. Here's our 9, it's higher than the mean. Here's our 6, it's a little bit lower than the mean. Here's our 7, it's a little higher than the mean. Here's another 8, right? And what we're interested in is how far are these scores from the mean? So we're interested in these distances, okay? And what we're doing when we figure out spread is we're sort of conceptually, we're figuring out the average. The average of all those distances. Average of the distances. conceptually, not quite mathematically. Each of these distances is called a deviation. Each of these distances is called a deviation. The way to calculate a deviation, I'm going to just abbreviate it DEV, and the formula is always X minus M, where X equals an individual score and M equals the mean of the data set. Let's go ahead and calculate the deviations for each people in our data set. 4 is the score minus the mean of 7 equals -3. This score is 8 minus the mean of 7 equals 1. 9 minus 7 equals 2. 6 minus 7 is -1. 7 minus 7 is 0. 8 minus 7 is 1. Any questions about what a deviation is? Then I'd like you to go in and take practice 3A, whatever the next practice is. I mean 3C. I think it's 3C, but it might be 3D. 3D. Go ahead and take 3D deviations. It should just take you a minute or two. I'll set the timer. Set timer for 2 minutes.
2 minutes, counting down.
Did you say 3D or 2D?
I'm sorry, 2D. Yeah, we're in chapter 2. 2D, thank you.